Hello, good evening. We are discussing question 8, which is discuss how AI is used in game playing and robotics. This is group 8. The group leader is Jafet Onyang. So Jafet Onyango will take us through question 8.
So question 8 says discuss how AI is used in game playing and robotics. First of all, we'll discuss how AI is used in game playing. So AI is frequently utilized in games to make human players' opponents more difficult and realistic, as well as to improve the overall gaming experience. Here are some of the instances how AI is applied into gaming. So the first one is strategic decision making. Here, AI uses a variety of algorithms and approaches, including search, assessment, and learning to achieve strategic decision making in gameplay mode. An overview of how AI facilitates strategic decision making in gameplay mode is provided below. So, alpha, beta pruning, and minimax search are two common search algorithms that AI uses to achieve strategic decision making in gameplay. So, based on the current state of the game, these algorithms search through the game tree to discover the optimal move the user can make or the AI can make. In order to find the move that will increase the player's chances of winning, the search procedure entails examining all potential movements as their results several moves in advance. So next we go to evaluation, how AI uses evaluation in the strategic decision making. AI algorithms uses evaluation functions to assess each move quality after the search process has identified the potential move based on a variety of variables, including the condition of the board, the placed pieces, and potential dangers and opportunities in the game. These evaluation functions provide a score to each probable move. The AI can rank potential moves and select the best one with the aid of the evaluation mechanism. Okay, so the second way AI is used in game playing is game balancing. In game balancing, the discussions are as follows. To keep the game challenging and interesting for the players and various skills level, game balancing in game refers to the process of modifying game mechanics, rules, and difficulty levels. AI achieves game balancing by examining player performance and behavior of data and modifying the game mechanics and difficulty setting as necessary. So in game mechanics and difficulty levels are dynamically adjusted in real time by AI algorithms that assesses the player performance data such as win or loss ratios. For instance, if a player is having trouble with a certain level or task, the AI program may change the level of difficulty to maybe amateur or offer recommendation to make things easier for them. Okay. Moving away from that, how AI is also used in game playing is to create the creation of non-player character. AI is used to generate non-player characters or NPCs in video games by giving them the ability to act intelligently and independently, much like human players do. Here are some of the significant ways that AI creates NPCs while playing video games. Using scenarios like cameras, microphones, or visual sensors, NPCs are trained to sense their surroundings. They have the ability to hear, see, and interact with other NPCs and game elements. So for example, while you are playing GTA or FIFA, there are several NPCs involved to make the game more interesting. For example, like FIFA, if you don't have an opponent, if you don't have a human opponent to play with, you can choose to play with the with the AI of the AI of the system, and you can set the difficulty level depending on your skill levels in FIFA. Okay. Other than that, NPCs are programmed to use reasoning to consider the data they have gathered and choose what to do. This uses methods like machine learning and decision-making algorithms. NPCs are designed with a set of behaviors that specify how they should behave in a specific circumstances. Okay. So for example, in real life examples, just like I said earlier, like GTA, there are several NPCs involved in the game since the game cannot function without non-player characters because it will take a lot of people to play the game for the game to be to a level more interesting. Okay, moving away from that. AI is also used in gameplay by opponent modeling. By utilizing AI algorithms to examine human player behavior and build models of their decision-making processes. Opponent modeling is accomplished in the game. This entails gathering information on the player's choice and results. Opponent modeling can be done using a variety of techniques such as rule-based systems, decision trees, Bayesian networks, and reinforcement learning. Although decision trees and Bayesian networks employ strategic models to predict the opponent's conduct based on observed data, rules-based systems use a set of predetermined rules to determine the opponent's behavior. Okay, moving away from that, a player application is also another way that AI is used in gameplay. By simulating human players and their activities in video games, AI improves the user experience by using the data to personalize the experience. AI algorithms can examine player behavior and preferences and utilize that data to personalize recommendations, adjust the game difficulty, and create material that is catered to the player's preference. For instance, AI can examine gaming data to establish a player preferred style of play and then modify the game difficulty to respond to the player's skill level. Additionally, AI can create customized game content based on the player preference and past gameplay, making for a more interesting and tailored experience. AI, moving on, AI can advise the best gameplay approaches, offer advice on how to overcome challenging obstacles, and even anticipate the player's next move. Overall, AI allows game designers to model players' behavior, preference, and skills, then use that information to improve the game mechanics and experience for them. Adaptive gameplay, I think, has been explained there above. It's just the same thing. So we'll move away from that to the procedural generation. So in procedural generation, using algorithms, procedural generation is the technique that is used in the creation of video games to automatically create game materials like levels, locations, and characters. All AI uses methods like machine learning, genetic algorithm, and cellular automata to achieve procedural generation in gameplay. This is how it goes. So in machine learning, algorithms can be trained on game content that already exists to identify trends and create new content that is similar in complexity and style. For instance, a machine learning system may study a collection of gaming levels and figure out how to create new levels with comparable layouts, challenges, and overall designs. So in genetic algorithms, to gradually change the content of the game, genetic algorithms imitate the process of natural selection. A genetic algorithm, for instance, might produce a collection of levels with various characteristics such as size, complexity, and difficulty. The algorithm then assesses every level according to predetermined standards such player involvement and choose the top level to breed with one another, creating new levels with a combination of the characteristics of the parent levels. So overall, artificial intelligence, AI techniques like machine learning, genetic algorithms, and cellular automata gives game developers strong tools to autonomously generate game materials, saving time and resources while offering a virtually limitless supply of contents to enjoy. So that is all we have on AI in game playing, but there are several stuff that we have not covered. Those are just the general ones that we could have covered in this documentation. So that's all.
Then AI and robotics, we now present and explain about.
Okay, I'll be explaining the use of artificial intelligence in robotics. So, robotics is just one of the many applications that artificial intelligence is used in. Robots that use AI are more effective, efficient, and versatile since it allows them to observe and react to the environment intelligently. Here are few robotics utilizing AI. Autonomous decision making. As for robots, they make judgments on their own without human intervention. This is enabled through the use of the AI algorithms in autonomous decision making. The fundamental actions that take AI to accomplish autonomous decision making in robots are listed below. Or for number one, we got perception. It involves using of sensors like cameras and sonars. The robot must be able to sense and comprehend its surrounding or the environment it is in. Or number two is the data processing. To complement the current condition of the robot and its surrounding, signals from the sensor are processed and analyzed, and AI algorithms employ the data analysis to plan activities that will assist the robot in achieving its objectives. So after analyzing the data, after perception, perception, and then data analysis, we've got now the decision-making point. This is where the robot itself makes a decision of what to do. The robot must choose what steps to take in the present scenario based on the action plan. And then we've got the execution. That's the main point where the main the main the main reason as to why it's built. The robot then it carries out the prepared activities to accomplish its objectives. Yeah, the main reason as to why it's built. While the robot continues to perceive, process, plan, choose, and carry out activities in its surroundings, these phases are repeated in loops. Robots learn through trial and error to improve their decision-making process because they are more like humans, so they are prone to errors too, which is which is how reinforcement learning and other machine learning approaches are frequently used in the AI algorithms used in autonomous decision making. Okay, that's all about autonomous decision making. Then number two, we've got collaborative robotics. Robots used in collaborative robotics can assist humans in a variety of tasks by working side by side with them. AI plays a significant role in achieving collaborative robotics. Robots can work alongside humans because they're more like humans in a safe environment thanks to AI algorithms that help them analyze and comprehend their surroundings and the task at hand. Robotics can detect the presence of humans using sensors, cameras, and they can change their movements to avoid accidents. Robots can adapt and get better over time by learning from their interactions with people. That's as they interact with people, they gain more knowledge about the environment that they are in, and therefore they improve their efficiency to accomplish their objectives. Okay. With the aid of the AI, this is made possible by machine learning, which gives the robot the ability to find patterns in the data it gathers and utilize this knowledge to enhance decision making skills as had earlier explained. Okay, the third point is computer vision. Through the use of cameras and other sensors, computer vision in robotics enables a robot to see its surroundings or the environment. Robots' ability to interpret the visual information gathered from these sensors depends heavily on AI. Yeah, AI algorithms are trained to do computer vision utilizing methods like deep learning, convolutional neural networks, the CNNs, and the recurrent neural networks on massive datasets of annotated images or videos, as your RNNs in short form. These algorithms acquire the ability to recognize patterns, classify objects in photos, and detection. Once taught, a robot's computer can use the AI algorithms to interpret images taken by its camera in real time. Following this study, the robot can decide how to navigate its environment, recognize and pick up objects, or avoid obstacles. For an instance, when we've got a robot which may be used for cleaning in a room. So let's say when it encounters a wall or maybe something else in that room, it may look for a way to to avoid hitting the objects, which may at times break it down, preventing its objective completion. Okay. Third, we've got natural language processing. Using methods like machine learning, natural language understanding, and dialogue management, AI delivers natural language processing in robots. The AI system can understand patterns and structures in natural languages since it has first been trained in extensive datasets of human language. Yeah, maybe the robots are first trained, like they're first trained to act like humans. In case, like for example, environment changes gender, they can be trained so as to act in human-like manner in those environments. Oh yeah, their systems can read and relate human language input using natural language understanding, the NLU techniques after being trained on language data. Now to do this, sentences and phrases must be broken down into their component pieces and the important concepts and topics be determined. Lastly, the system can generate acceptable response to inputs in human language by using dialogue management techniques. This entails choosing the best answer depending on the context and intent of the user's input, as well as any other pertinent aspects like the robot's present conditions or its surroundings. Overall, artificial intelligence enable natural language processing in robotics by combining machine learning, natural language understanding, and dialogue management techniques to give robots the ability to comprehend and to react to human language inputs in a natural and intuitive way. Intuitive way. Okay. Next, we've got the question chosen by our group, which will be the summary will be done by Meshak.
So in this question, we looked at the definitions, examples, programs, and applications. And the question we chose was, what is inductive logic programming? So in the introduction, inductive logic programming is a branch of machine learning called inductive logic programming that seeks to learn logical principles or programs from examples. To learn these rules, inductive logic programming uses methods from machine learning, logic programming, and inductive reasoning. Inductive reasoning entails inferring generalizations from specific observations or examples. Then we have the main aim of inductive logic programming is to learn a set of logical rules that can be applied to forecast the outcome of fresh data. These regulations are frequently written out in a logical programming language like Prolog by fusing the instances with background knowledge. These systems provide candidate hypotheses or logical principles that can explain the available examples. The hypotheses are then assessed by determining if they are consistent with the data that is currently used. So the inductive logic programming uses inductive reasoning, which involves drawing generalization from specific observations or examples. In inductive logic programming, the learning process involves the following steps. background knowledge, example generalization, generation, hypothesis generation, and hypothesis evaluation. So I'll discuss background knowledge. In inductive logic programming, the background knowledge refers to the prior knowledge or domain knowledge that is available to the system. This knowledge is represented as a set of logical rules or facts that are assumed to be true in the domain or interest. Background knowledge is used by the inductive logic programming system to generate candidate hypotheses and to evaluate them. It can also be used to guide the search process and to constrain the search space. Then the second one is example generation. The inductive logic programming systems generate examples from the available data, which can be in the form of positive and negative examples. Positive examples are instances that belong to the target concept, while negative examples are instances that do not belong to the target concept. The inductive learning logic programming system uses these examples to generate candidate hypotheses. Then hypothesis generation. In inductive logic programming, hypothesis generation refers to the process of generating candidate logical rules or hypotheses that can explain the available examples. The system generates hypotheses by combining the background knowledge with the examples. The generated hypotheses are then evaluated to determine their consistency with the available examples and the background knowledge. Then hypothesis evaluation. In inductive logic programming, hypothesis evaluation refers to the process of evaluating the candidate hypothesis generated by the inductive learning logic programming system. The evaluation processes involves checking the consistency of the hypothesis with the available examples and the background knowledge. The inductive logic programming system evaluates each hypothesis based on its ability to explain the available examples while minimizing the number of exceptions or errors. Then examples of fields where inductive logic programming is applied. In this, Brian Ukungu will help us explain more.
No. In the fields where inductive logic programming is applied, we have robotics, bioinformatics, computer vision, natural language processing, data mining. So because of time, I'm just gonna explain three of them. The first three, we have robotics, where the inductive logic programming can be used to learn model of robots' behavior from observable example, allowing robots to learn, adapt new environments and tasks. For example, you can have like some cleaning robot which is trained to according to given some data to train on how to clean a room. So inductive logic programming has been used to learn model for visual object recognition and manipulation by robots. In bioinformatics, induction logic programming can be used to learn patterns rule from biological data such as gene expression data and protein structure data. For example, it has been used to learn rule for predicting protein-protein interaction for identifying drug targets. Lastly, computer vision. Both like in computer vision, we have something like facial recognition. So inductive logic programming can be used to learn model for object recognition. So for example, facial recognition,
image classification, other tasks like so for example, facial recognition and image compression. Next we go to examples like libraries that are used in inductive logic programming. You have Aleph, tilde, quick foil, and so we discussed only three because we saw those were our research. We only got three of them. So let's see what in RFL is a popular inductive logic programming system that is written in Prolog. It supports both supervised and unsupervised learning and can handle variety of data types, including relation data and propositional data. Aleph provides several algorithms for learning logic program, include first order induction of decision tree and first order induction learner. Aleph also provides tools for data processing and post processing such as feature selection and rule optimization. The second one is title. The second one is title, and in induction logic programming system that induction programming logic programming system that is written in C++. It also supports supervised learning like Aleph and can handle both preposition and relational data. It will provide several algorithms for learning logic programs, including decision tree, like decision tree, decision list, and covering. It will also provide tools for data post-processing, such as feature selection and rule optimization. Then lastly, we got quick foil. Quick foil is it's also written in C++. It supports supervised learning of classification, same as tilde. Regression task can handle position data. It's quite the same like tilde. Quickfoil is based on foil algorithm and provides several enhancements such as pruning and rule optimization. So I think that was the last one, huh? Then I think we looked at how its algorithm can be written. So is the program, how it can go. You define the learning problems. Like first step is writing an inductive logic programming and define the learning problem. This involves identifying the input and output of the program and how much time an input can take to execute. So the second step, choose an ILP algorithm. Once the learning problem is identified, next step is to choose an appropriate algorithm that can learn a logic program that satisfies the constraint and requirement of the problem. Here is where we use several APL algorithms such as FOIL and Aleph, the ones we learned above, those libraries. Then third step, prepare the data input. Prepare the data like the input data that is suitable in a suitable format for the chosen algorithm. Let's say if you choose Aleph, you have to choose appropriate data that will satisfy the algorithm. Then the next step is to run the ILP algorithm. once the data is prepared, the inductive logic program algorithm can be run to learn a logic program that satisfies the constraint and requirement of the problem. Then the last step, evaluate the learned program. The final step is to evaluate the learned program to determine its accuracy and performance on new data. So let's say maybe you have taken the suitable data, then divided it into training and testing data. So after testing it, you come up with the results, the accuracy and performance. Then after that, you take a new data and test it. So that would be the final. That would be the final. Final step. And I think that's the work we managed to do as a group 8. We discussed the work, and this is the output. We are very proud of ourselves because the effort we have tried. Sure, we deserve some. We deserve some good marks. As you can see, the work is good and clean.